Hello guys, welcome back to PHY Science. In this video we will be doing 2026 test 2 for physics 1121 question 2. In our previous video we did Newton's law and work energy theorem. You can check for it in the link under the comment section. Question 2, 2.1. Calculate the work required to move an Earth satellite of mass m from a circular orbit of a radius 2re to one of radius 3re. First of all, we remember that an orbit, it is just a circular imaginary line where planets they orbit around or they move around. So, what is keeping those planets from not falling when they circulate? There is a certain force called gravity. We know inside the Earth, gravity pulls everything downwards. But on the orbit, it's a different story. Gravity pulls all the planets towards the center. So if we have a force that pulls things towards the center, isn't it that the same as a centripetal force? That's why then we say force gravity, it is equal to a centripetal force. While we know that force of gravity, according to universal gravitational law, it is equal to g m1 multiplied by m2 all over r square. And the centripetal force, it is given by mv square all over r. So what you can do from here, you can multiply by r all over m, which will give you gm all over r on your left hand side, which will be equal to your v squared. Remembering that to move a satellite, it will need an energy, and there will be a certain speed, which is just a definition of kinetic energy. So you write your formula for kinetic energy, it is equal to 1 all over 2 mv squared. And now you calculated that v squared is equal to gm all over r, which means you will substitute in the value of v squared. At the end, you will have your kinetic energy equal to gm multiplied by your small m all over 2r. From your grade 12, remembering that work done by Fg or work done by your weight, it is equal to negative mgh, which also mgh, it is the same as potential energy, which makes work done by Fg to be equal to negative potential energy. And again, we know that work done by a force, it is equal to that force multiplied by the displacement multiplied by cos of theta, which if we are integrating it, it will just give us simply work done by a force to be equal to the integral sign and the force multiplied by the displacement. And according to universal gravitational law, force of gravity is equal to g big M multiplied by small m all over r square, which means we can substitute in the value of F with our gm multiplied by small m all over r squared, which if we rearrange it, it will give us g big M small m multiplied by r raised to the power negative 2. So remembering the power rule, that when we are integrating, let's take for x in respect of x, it will be equal to x. In its exponent, we are going to add 1. Then we take the new exponent, we divide by it. So if we add 1 on negative 2, we are going to get negative 1. And when you divide by negative 1, this will give us negative gmr to the power negative 1. Which if we rearrange it, it will give us the work done by gravity to be equal to negative gm multiplied by small m all over r, which is not 2, because gravity in the orbit, it is forcing every object to move towards the center, which means it is doing a positive work. Remembering again that we said work done by gravity, it is equal to negative u, which means we'll equate this to negative u, which then make our u to be equal to negative g big M multiplied by small m all over r. So far, we managed to get the formula for kinetic energy and the formula for potential energy. But with this information, we know that kinetic energy, when you combine it with your potential energy, it gives you your mechanical energy. So you can substitute what you got as your kinetic energy, which is g m small m all over 2r minus, since the value of your potential energy is negative, your gm multiplied by small m all over r. From here, you can see something in common, which is your gm small m all over r. So you will factor it out. You will be left inside with 1 all over 2 minus 1. So if you press your calculator, at the end, it must give you negative gm small m all over 2r, which is your mechanical energy. Remembering again from grade 12 that work net, it is equal to change in EK, which is your kinetic energy. Why they were saying kinetic energy? Because we were dealing with an object that was moving. But basically, work net, it is equal to change in energy. In this K, which our energy is our mechanical energy. So, which makes our work net to be equal to change in mechanical energy. But what is your work net? Because we know that when we are dealing with work net, we have to sum work done by different forces. In this scenario, we want to move a certain satellite, which means we have to apply a certain external force to move it. So our work net will be our work done by external forces, which will be equal to your change in mechanical, which will be your mechanical final minus by your mechanical initial. From here, you substitute in your values of mechanical with your negative gm multiplied by small m all over 2I minus, there is a negative sign for the formula and a negative sign for emec. So it will be positive gm multiplied by small m all over 2r. So your r final, they said we want to move it, or your radius final, they said we want to move it to a radius of 3re, and your initial, it was on 2re, which means you can now substitute on this part of your final on your radius with 3re, on your initial part with 2re, which will give you negative gm small m all over 6re plus gm small m all over 4re. So from here, you can take out your gm small m all over re, which you will be left with negative 1 all over 6 plus 1 all over 4, which at the end, if you press your calculator, it must give you g big M small m all over 12 re, which is the work required to move an Earth satellite from the first orbit to the second orbit. Let's move to 2.2. They say a bead slide without friction on a loop, the loop track as in the figure 2. Let me try to draw the figure below. Then they say the bead is released from rest at a height which is equal to 3.5 r, where r is the radius of the loop. And the first question, 2.2.1, what is the speed of the bead at point A at the top of the loop? First thing to do, note in the statement they said without friction. So when they say without friction, they are meaning energy it is conserved, or there is no energy lost. Okay, let me make my highest point of the track to be P. So if my highest point of the track is P, which means energy at P, it is equal to energy at A. Checking from my point P, the bead was at rest, which means initially I was having only potential energy. And we say that potential energy, it is equal to mgh, which means energy at P, it is the same as mgh. But energy at A, my bead was already moving, which means now it have potential energy and also kinetic energy, because it still have a certain height. So I will have mgh equal to mgh plus 1 all over 2 mv squared. From here, I multiply both sides of the equation by 1 all over m, which will give me gh equal to gh plus 1 all over 2 v squared. Substituting my height at point P, I will have 3,5 rg. Then, again, I have to substitute my height there at point A. Point A, it is actually twice r, because we are given that the radius of the circle is r. So moving from the ground to the center, it's r, and from center to point A, it's another r, which will be our 2rg plus 1 all over 2 v square. Taking like terms to one side, you will have 3,5 rg minus 2 rg. It is equal to your velocity at A squared. I mean the half velocity at A squared, which if you press 3,5 minus 2, it gives you 1,5. So you have 1,5 rg equal to 1 over 2 the velocity at A, but you don't want half the velocity at A, so you will multiply both sides by 2, which will now give you the velocity at A squared to be equal to 3 rg. And you don't want the velocity to be squared, you will introduce the square root both sides, which will cancel with the 2 in the velocity of A, which at the end will give you velocity at A to be equal to the square root of 3 rg. That's your answer. Let's move to 2.2.2. If the mass of the bead is 5 grams, what is the magnitude of the normal force exerted on the bead at point A? First of all, you draw the free body diagram for the bead at A. So you will have your normal force going down. Why perspicacious is it going down? Because when you are dealing with a centripetal force, the normal force must go towards the center in order for the object not to fall. And your weight, as usual, it always goes downward. Then after this, you drop your F net equal to ma. So the sum of your forces here, it will be your normal force plus your weight, which is your mg, which will be equal to your ma. And you know that acceleration, it is given by v square all over r. But you remember that you calculated v to be equal to the square root of 3 rg. So you will substitute there instead of v. And when you are substituting now, the exponent 2 in v will cancel with the square root, which will then give you m3rg all over your r. Your denominator r and your numerator r, they are just r, so they will cancel, which means n plus mg will be equal to 3mg. So you take mg to the other side, which will make n to be equal to 3mg minus by mg. At the end, your n will be equal to 2mg. And you are given the mass now to be 5 grams. Then how do I convert from grams to kilograms? You simply multiply the value that you are given by times 10 to the power negative 3. So you will come back and substitute 2 then into your 5 times 10 to the power negative 3. You know the value for 9 for g, which is your 9,8. Then you press your calculator. At the end, you will have 0,098 newtons, which will be your normal force. Thank you for watching this video in Perspi Science. See you in question 3. Don't forget to like and subscribe to be notified with more video updates. Thank you.